Hey. Okay. So yes, this is a pipe. Apologies to René and Marguerite. So you heard about currying functions. You know, a function that if you call it with fewer than all its arguments, you get something callable back that is callable with the rest of the arguments. I want to have that, but I want to have a right curry, so that if I call it with fewer than all the arguments, I want to bind the rightmost ones, so that if I call it with something else, it will be the arguments to the left, and we'll come back to why. So we have this struct right curry that takes size t, that is the arity of the function, the number of arguments it takes, and f is the function type. And I have a member f for the function. So I can do something like this. I create a minus that is right curry of stud minus, or equal to that is right curry of stud equal to, both a binary function, hence the 2. And we can do absolutely nothing with this because we're not done yet. But then we can add an operator function call. So we say if this right curry instance is called with arguments that our function is invocable with, then we return the result of invoking it. Okay, cool. So I can now write something like this. I have my minus, that is a right curry of 2 and stud minus. And if we call minus of 5, 2, it calls stud minus of 5, 2, which is 3, which is unbelievably unimpressive, but it's a start. Because now we come to something. We have also another function call operator, but requires size of the arguments is less than n. So I'm calling with fewer arguments. So we can use a standard library and create a new function f here with stud bind back. Stud bind back the function and the arguments. So now we have something that is callable, and we have bound the last arguments to it. The return type of stud bind back is unspecified, but decal type to the rescue. So we can return a right curry of n minus the number of arguments and the type of f instantiated with f. So now I can create, again, this minus that is right curry of 2 and stud minus, and I can create something that is minus 2, that is call minus with 2, and if I call minus 2 with 5, that means calling stud minus of 5, 2, which is 3. Okay, we're on to something. Because now we create a pipe. The pipe takes another function, and we create a function that is the result of calling the new function, the RH, right-hand side argument, with the result of calling the existing function with the arguments. So f is a lambda that binds LH as the current function and RH as is. And when called with a number of a's, it returns RH of LH of all the a's. And we can again return a right curry of that with n, the same cardinality. This has not changed. Decal type of f, so we get it, and the instance of f. So now I can have my minus as before. I can have equal to, that is a right curry of 2 and stud equal to. And we can create a function that is minus 2 pipe equal to 3. So if I call this function with 5, it calls minus 5, 2, which is 3, and it calls stud equal to of 3 with 3, which is 2. So we're on to something. This is cool. So a little helper, if I want to carry some any function at all, we create this all carry func that takes as template parameter the arity of the function, some type f for the function, and we create right curry of that cardinality and the type of the function and the function instance. So now, in addition to our equal to and such, we can create a get that is a right curry function of stud get. And I have to use a lambda here to make an indirection, because stud get is not a function, it's a function template. We need to figure out which is which instance of the function template, create an instantiation of the function template. So with this, we can create our main function. I have an array of pairs of string view and ints, and we have a bunch of numbers in string representation and as integers. Find if of this array get 0, that is the words, pipe the result of get 0 to equal to the word 3. And then we return the, if we got the end, we return 0, otherwise we call get of 1, that is the numbers of the iterator. And doing so results in this code gen. And that Godbolt link proves it. And this is awesome. It's absolutely amazingly awesome.
No, you have to put it in a function and then see the function in isolation.
This is cool. This is super cool. That is undeniably super cool. I don't know if it's a good idea, but it is super cool. And that is all I wanted to say. Thank you.